Rubber overmolding. Processes, types, and regulations. This video will provide a reader with more information regarding topics, including various processes of rubber overmolding, design considerations for rubber overmolding, types and grades of rubber overmolding, rules and regulations of rubber overmolding, quality control for overmolding, additional considerations regarding rubber overmolding, negatives and limitations of rubber overmolding, benefits of rubber overmolding, industrial applications of rubber overmolding, the future of rubber overmolding, and much more. Chapter 1. What are the different processes involved in rubber overmolding? Injection molding. Compression molding. Transfer molding. LIM liquid injection molding. Two-shot molding, also known as dual-shot molding or overmolding. Chapter 2. What should be considered in the design of rubber overmolding? Material compatibility. Surface finish. Tolerances. Undercuts. Wall thickness. Draft angles. Additional design factors in rubber overmolding. Beyond the primary elements outlined above, several advanced considerations can further optimize your rubber overmolding project. Gate location. Venting. Bonding methods. Environmental exposure. Chapter 3. What types and grades of rubber are used in overmolding? Silicone rubber. EPDM rubber. Neoprene rubber. Natural rubber. Nitrile rubber. Other specialty rubber materials for overmolding. Rubber grades and industry standards. Frequently asked questions. What are the main processes used in rubber overmolding? Which design factors are critical for successful rubber overmolding? How do you choose the right type and grade of rubber for overmolding? What role does material compatibility play in rubber overmolding? Why are rubber grades and industry standards important for overmolding? Which rubber types are commonly used for outdoor or automotive overmolding? Chapter 4. What are the rules and regulations governing rubber overmolding? Chapter 5. What are the quality control measures for overmolding? Molding conditions. Surface finish. Dimensional accuracy. Material properties. Performance testing. Inspection techniques. Documentation and traceability. Chapter 6. What additional factors should be considered in rubber overmolding? Tooling. Cost considerations. Environmental considerations. Chapter 7. What are the negatives and limitations of rubber overmolding? High tooling costs. Limited design flexibility. Material compatibility issues. Limited production volume. Limited material options. Quality control challenges. Chapter 8. What are the benefits of rubber overmolding? Some of the key benefits of rubber overmolding include enhanced product performance, greater design flexibility, cost-efficient production, enhanced product aesthetics, improved ergonomics, increased resistance to wear and tear, effective waterproofing and sealing, noise reduction, thermal insulation, Chapter 9. What are some industrial applications of rubber overmolding? Automotive industry. Medical industry. Consumer electronics. Industrial equipment. Aerospace industry. Sports and recreation industry. Toy industry. Military and defense industry. Chapter 10. What does the future hold for rubber overmolding? Advancements in materials. Automation. Sustainability. 3D printing. Conclusion. Please visit www.iqsdirectory.com to find the right rubber overmolding manufacturers for your needs.